Hi guys, today we are going to chat a little bit about these three equations. So we have here equation 1, equation 2, and equation 3. And we are going to try to figure out which one is always true, sometimes true, or never true. So we are working with some always true, sometimes true, and never true. So what I'd like you to do right now, there will be a box that pops up for you, and I want you to do some scrap work off to the side or take a look and try to examine these equations and let me know if you think equation 1 is always true, sometimes, or never true, what you think about equation 2, so always true, sometimes true, or never true, and lastly, equation 3. Is it always true, sometimes true, or never true? Think about what you could do to maybe try to solve that and sort of reach that goal there of determining which is which. All right, now that you've filled in the box question, we can move forward with our lesson today. So today we're going to talk about how to figure out if equations are always true, sometimes true, or never true. And we are going to start with this very first equation. So I am going to try to solve for x here. And when I do that, I think that will reveal quite a few things if it's always true, sometimes true, or never true. So the first thing that we want to do is distribute the 3 to both sides. So 3x plus 6 is equal to 3x plus 2. So right away, I'm taking a step back and I'm looking at this problem, and I can see that if I have x, so remember x could be any value. If I have x, I multiply it by 3 and then add 6 to it, and then I take that same x, I multiply it by 3 and I add 2 to it. Will these two sides of the equal sign ever be the same? So taking a number, multiplying by 3 and adding 6, and then taking that same number, multiplying by 3 and adding 2, and the answer is no. So this is never true. And for problems that sort of aren't this obvious that it's never true, let's go ahead and keep solving so that we can figure out what that would look like in the very end. So the first thing that I want to do is I want to try to get my variables together. So I am going to subtract 3x from both sides. And when I do that, my 3x cancels out over here, but you'll notice my 3x also cancels out over here. And I'm left with 6 is equal to 2. And is that true? That is not true. So that is why this equation is never true. So if you try to solve and your variable goes away like it did here, right? We were able to subtract 3x from both sides, and you're just left with something that's just plain just not true. So like 6 equals 2. I know that this is an equation that will never be true. So let's take a look here at this one. So again, we're going to solve. So this one is either always true, sometimes true, or never true. And I'll start by distributing. So 8x minus 10 is equal to 18 minus 6x. And from here, I will continue to solve. So I will add 6x to both sides. And when I do that, I'm left with 14x. Minus 10 is equal to 18. I can add 10 to both sides, so 14x is equal to 28. I can divide both sides by 14, and I'm left with x is equal to 2. So I was able to reach a value. So this feels very familiar. This problem feels very familiar to what you did on your test, to what we've been doing for a few weeks now in solving equations. This is an example of something that is sometimes true. This is an example of something that's sometimes true. This equation here is only true when x is equal to 2. If I were to plug in any other value, this would not be true. So this is only true. This equal sign only holds up when x here is 2. So that is why it is sometimes true. So let's scoot down to our last problem here. And if I take a look, I again want to solve this. And I want to point out two things. Number one, Remember that the sign that is in front of the term is the sign that belongs to that term. So here, there's no sign out here, so there's really, this is positive 12. And here we could read this as negative 5. So I have positive 12x minus 5. And then here, I have a negative 5 and a positive 12. So we can see that there are really similar things on both sides of that equal sign. So the first thing that I want to do is, again, combine my variables and get them both on the same side. So I'm going to subtract 12x from both sides. And when I do that, it simplifies over here and also over here. So this is really similar to the first problem that we solved together, where my variable just all together canceled out. So let's see what I'm left with. I'm left with negative 5 equals negative 5. And this is always true. So this means that no matter what value I plug in for x, this equal sign will always hold up. I'll multiply that number by 12 and then I'll subtract 5 from it. And the same thing over here. I will multiply that number by 12 and then I'll add negative 5 to it, which we know is the same thing as subtracting 12. So that's why this equation is always true.